So as you can see in each of these pic, here mango is falling from the tree. In second, a skydiver falling towards the ground. In third one, you can see a stone dropped from a building. So all of them are falling towards the ground. So what are the forces acting all these falling bodies and why they always go towards the ground? All these questions we will be seeing here. So the gravitational force and the air resistance in all these you can see, because there is a air resistance, they are acting in opposite direction. But if we neglect the air resistance, which is a small force, those bodies will be under the action of gravity alone. If we neglect air resistance, why bodies are falling towards the ground? Because air resistance is smaller than, yeah, I mean the air resistance is in the upward direction, but still that force is not able to take the mango in the upward direction. Why? Because it is smaller than gravitational force. So if we neglect air resistance, because it is very small force, so we can neglect it. So these bodies will be under the action of gravity alone. And when some objects, any body or object is falling only under the action of gravity, it is called free fall. So the objects moving under the action of gravity is said to be in free fall. So basically here, uh, now let's see, um, like what is free fall and what is the conditions and all. So if you consider a ball dropped from the top of the building at position A, the ball is just dropped. So its initial velocity, its initial speed is 0. But at position B, the body is in its path, right? It's going down. So its velocity is not 0. It has some speed now, right? So as it is going down, its velocity is increasing throughout its motion. Why? Because of gravitational force which is acting towards the center of the earth. I mean the earth gravity or acceleration due to gravity is, um, like pulling it towards the ground. So free fall is an accelerated motion. Accelerate means if its velocity is increasing, that is called accelerated motion. At A it is 0, at B it is suppose 5 meter per second, at C point somewhere here it is 10 meter per second. So it is increasing. So the ball is under a constant gravitational force which is exerted by the earth. Now Newton's second law says that acceleration of a moving body is directly proportional to force to which it is subjected to. Suppose I increase the force, so acceleration is also going to increase. This is what Newton's second law of motion says. Acceleration means change in velocity, okay, with time. So acceleration of falling ball is constant throughout its motion as the gravitational force is constant. It is fixed. So the gravity or acceleration due to gravity, we represent it with small g, which is uniformly accelerated motion, because acceleration is increasing but in a uniform way. Um, so acceleration which is experienced by a freely falling body, freely falling means there is only gravity on earth, so it is called acceleration due to gravity. We denote it with letter small g. Its unit is meters per second square. It is same as acceleration, right, which is velocity over time, speed over time. Suppose you have a mass and its mass is m and it is falling under the earth's gravity, okay, and suppose the mass of the earth is capital M and r is the radius of the earth and height at which object is located from the earth is r. You can see this is the height. So Newton's second law says that F is equals to ma. F is force, m is mass, a is acceleration. Because here it is falling under the gravity, so A will be replaced by G, which is acceleration due to gravity. Now there is a law which is called universal law of gravitation, which is this: force of gravitation is G, which is a constant, both mass between which force of attraction is, like this mass and the mass of earth. So this is mass of stone and this is mass of earth, and the distance between these two is r, so r square. Now if we plug, because as according to Newton's second law, F is equals to mg, right? So at place of F I can write mg. Now from here, if I divide both sides by m, this m will cancel out and we will just get g, and there I will get m. So this m and this m will cancel and we will get g is equals to gm over r square. This capital M is the mass of the earth. R is the distance between this stone and the earth. So this is the formula for acceleration due to gravity. If we plug the value of g, which is this, and m is the mass of earth, is this, r is the radius of earth. So if we just plug all these value, we will get g, which is 9.8 meters per second square, which is acceleration due to gravity on earth. Okay, now let's see, is the acceleration due to gravity same for various object which is falling towards the earth? Like here you can see there is a stone and a feather. What do you think, which one is heavier? Yes, stone is heavier than the feather. So for them the acceleration due to gravity, should it change? So let's see. So two objects, they need to be, if like you take them and drop them from the same height to check if they like land at the same time, that means the acceleration or the gravity is same, otherwise not. So if let's say you take a box, you like there you keep the air resistance 0. I mean, no, you just take it in inside this box. So if a feather and stone, if you drop them at the same time, the stone lands first and feather lands next. This is because air resistance acting on the feather is greater than the stone, okay, which reduces its speed. Air resistance is acting in the upward direction, and because there is a force which is pulling it in the upward direction, so that's why its speed is less or great, I mean less than the stone. This is done in a glass tube, that so that the air resistance is like if here we do it in the glass tube and we eliminate the air resistance, then the two will land at the same time. Okay, so acceleration due to gravity. So it was believed earlier that acceleration of a falling body depend on its mass, but in the 16th century Galileo proved that this to be wrong by dropping two objects of different masses from the top of the Tower of Pisa. So acceleration of freely falling body is independent of its mass. Okay, it does not depend on the mass. It is always 9.8 meters per second square. Okay, like here we can see we put the value, the mass of the earth. So mass of the earth is going to be same. It is not dependent on the mass of the body. Okay, now mass and weight. So mass of a body is a measure of the amount of matter contained in a body. So whatever it is made up of, whatever matter it is made up of, that is called mass. And it is a measure of its inertia. Inertia means like the resistance in change. So mass unit, SI unit is kilogram, and it remains same everywhere. So because it only has size, it does not depend on direction, which is called scalar quantity. It just has a value, it does not have a direction. Now weight of an object is the force with which it is attracted towards the earth. That is m times, again Newton's second law, Fm times a. At place of a we plug g here because g is the acceleration due to gravity and a is just acceleration. So weight formula is this, m times g, and its unit is Newton. Okay, so it will vary from place to place because the value of gravity g, it changes from place to place, right? So weight of an object on moon is the gravitational force with which moon attract it. So as the mass of the moon is smaller than earth, so basically it will exert lesser force of attraction on objects. Weight of an object on the moon is equal to the gravitational force with which the moon is attracting the object. Like here, if we calculate, this is the formula for weight. G is constant, m is mass over r square. So if we plug the value of g, the mass of the moon, which is this, and the radius, which is this, of moon, we will get, and if here we plug the value of earth, so the value is going to be different. Like here you can see the weight is the ratio is 0.165. If we compare the weight on mass, I mean the weight on moon and earth, so which is nearly equal to 1/6. So the weight of an object on moon is 1/6 on the earth. So suppose there is a person of mass 55 kilogram on earth, so its mass on the moon is going to be, how can we calculate? By dividing it with, like this is the weight, right? I mean, sorry, this is the mass. The formula for weight is mass times gravity. So this is the formula, mass times acceleration due to gravity. Its value is fixed, 9.8. So mass is 55 times gravity is 9.8. If we times it, we get this. This is the weight on earth, 539 Newton, and the weight on the moon will be, if we divide it by 6, because it is 1/6 of earth, so we get 89.83 Newton.